Good afternoon. You've watched a lot of videos on linked lists. I'm going to show you a little bit of an illustration about how linked lists work and how you can use them and why you never actually have to implement them. Hey, you want to know a secret? You're never ever going to be paid to implement a linked list data structure. In order to understand why linked lists are so powerful, let's have a look at a simple problem, which is the problem of inserting a new element into a collection. Consider the situation where we have four students. We have Aaron Smith, Bobby Bear, Sierra Ling, and Zoe Peters, and we have stored them in an array. A new student arrives, Peter Smith. We now need to add them to the collection. In this example, we are storing our students alphabetically by the first name. That means that Peter Smith needs to be inserted between Bobby Bear and Sierra Ling. We need to make sure that our array has room for Peter Smith. In this particular example, let's assume that we do actually have room for Peter Smith, as you can see by the illustrated empty space at the end of the array. Okay, since we have room in the array, we can copy Zoe Peters down to the end of the array and do the same thing for Sierra Ling, leaving us space to insert Peter Smith into the array. In order to insert one piece of data, we had to move half of our data. Imagine if we had millions of pieces of data, we would have to do a lot of work. There has to be a better way. Linked lists are the way. In this video, we are going to walk you through the concepts of how linked lists work. The purpose of this is so that you understand the benefits of linked lists and when to use that as a container in the future. Remember, in a computer, all of the data is stored in memory. And in the previous example, we were showing arrays and trying to insert data in an array. That means we had to copy stuff around in memory. Okay, let's build a linked list. First, we need a variable that tells us where the linked list is. We're going to call that variable students, and initially it's going to point to null. Visually, we use this square line that points down to ground to indicate that the variable students has a value of null. So now we're going to build our linked list. The first thing we want to do is insert Aaron Smith. What we do is we allocate some memory, and then we set the value of that container to be Aaron Smith. Then we set the next pointer of that node or element of the linked list to be null, and then we set the pointer of students to be pointing at Aaron Smith. Now we're going to do the same thing for Bobby Bear, Sierra Ling, and Zoe Peters. So what do we do with Peter? Previously, we added our new students at the end of the list because they were all coming in alphabetically. Peter has to be between Bobby Bear and Sierra Ling. Let's see how we do this with a linked list. The first thing we do is we ask the operating system for a new piece of memory where we are going to store the data for Peter. Notice that I have drawn the new memory for Peter Smith in a completely different part of the Blackboard. This is to indicate that this memory can be anywhere in the computer. Peter Smith has a next pointer, and the next element from Peter Smith needs to be Sierra Ling. So we set the value of next for Peter Smith to point at Sierra Ling. The next step is to make Bobby Bear point to Peter Smith. We do this, and the result of that is that the list is now complete. So how do we use this data now? What we can do is we can start with students and we can just keep following the pointers as we progress across the list. We would go to Aaron Smith, and then that has a valid pointer, so we can go to Bobby Bear, and that has a valid pointer, and it would go to Peter Smith, and then to Sierra Ling, and then to Zoe Peters. When we get to Zoe Peters, we notice that the next pointer for Zoe Peters is null, and therefore we are done. So we can build the linked list. Now, Bobby Bear went and got a job. So we're going to have to remove Bobby Bear from our list of students. How do we do this? Bobby Bear is between Aaron Smith and Peter Smith. It's quite simple to delete a node. What we do is we make Aaron Smith point to Peter Smith. Notice that Bobby Bear is still pointing to Peter Smith. But that doesn't matter because what we're going to do is give Bobby Bear back to the operating system and we will never reference that again. Okay, let's play with some code. I'm going to walk you through some simple Python code that implements a linked list. The first thing we need to do is define the node that is going to be a part of the linked list. In Python, this is fairly straightforward. We set a class that has a data element and a next element. We are going to define a linked list class, and it is going to have a variable that will store the location of the beginning of the list. We're going to call this self.head. Using our old illustration, we can see that self.head is actually pointing to none in Python. In our previous example, we used append to add new elements at the end of the list. Let's see how this works in Python first. Our append function is called with some data. So the first thing we do is we create a new node. If the head is pointing to none, then that means the list is empty. So all we have to do is point the head at the new node and we're done. Here's the code that we wrote to drive our test sample. You can see that we add all 4 people in the order that we did in our example. So after adding a node to a linked list that has no nodes, we notice that we have a pointer to that one node, and that node is pointing to none. The next step is to add Bobby Bear to this list. When we start running this code, the head is pointing at Aaron Smith. So we skip that first if statement, and then we move to the second part. In our example here, last node is pointing at Aaron Smith, and Aaron Smith doesn't have a next value. So we skip that while loop, and then we update last node next to be equal to the new node. Okay, so now we're going to add Sierra Ling to this linked list. As before, we skip the first part because the head is pointing to Aaron Smith. So now we end up at the point where last node is pointing at Aaron Smith. Notice that last node next is not null in this situation. So in the while loop, we update last node to be the pointer that last node points at. Now, last node points at a node that contains Bobby Bear and has none as its pointer to the next node. So we exit the while loop and we update last node next to be equal to the new node. The important thing to notice here is that this update has actually completed the linked list, because when you look at the linked list starting from head, you see that it points at Aaron Smith, Bobby Bear, and Sierra Ling. Repeating this step one more time results in Zoe Peters being added at the end of the linked list, and our original linked list is now complete. Phew, that was a lot of work to build a list, but then you know what happens. Peter comes along, and we have to insert Peter into the class. So we have the ability to build a list, and we're about to insert in the middle. Before we do that, let's have a look at the print list thing so we can see how to iterate over a linked list. It's quite simple, actually. If the list is empty, we print self.head points to none, and we are done. If the list is not empty, we are going to execute this while loop. If an element has a next pointer that is valid, we print out the data and a little arrow. If the element is the last element of the list, we print out that element's data and none next to it. Okay, so now we want to insert Peter Smith after Bobby Bear. Insert after node is a simple routine that finds a node and inserts new data right after it. So what we're going to do is we're going to have a look and see how that works. So we need to find the correct place to put Peter Smith, which is right after Bobby Bear. Let's see how this works. So we're going to iterate over the data. The first thing we need is a pointer to where we are in the list. So we use car node and set it to the value of self head. We're then going to iterate until we either run out of data or we find the node that we're looking for. If we can't find the node, then something went wrong, so we return. And here is where we do the work. We allocate a new node and we update the pointers such that the new data is in the list. Okay, so let's insert Peter Smith. We start off with current node pointing at Aaron Smith. Current node points to Aaron Smith. So we're going to go in here and we're going to update it so that it points at the next. Now current node is pointing at Bobby Bear, which is what we're looking for. Therefore, we break out of there and we can continue. We create a new node with Peter Smith as its value. We then make its next value equal to the current node's next value. And then finally, we take the current node next and we point it at the node that we just added to the list. When we do this, we have completed our list and we have duplicated in code what we did earlier with diagrams. There's two people that complicate this whole situation. One is Peter Smith, who joins the school, and the other one is Bobby Bear, who went off and got a job. So the final thing we have to do here is figure out how to delete a node from the linked list. Okay, let's delete Bobby Bear since he went off and got a job. Here's a delete node code. Let's walk through it and see how we can delete items from a linked list. We are going to set up a current node as an iterator. There is a special case where you have to delete the first element of the list. I encourage you to read up on that in your own time. We set up a variable called previous to remember the previous node. We will use this when we update the data at the end of this method. Now we iterate over our list until we find the data. When we start, we notice that our current node is not equal to Bobby Bear. Since we have not found Bobby Bear, we update the previous pointer to be equal to Aaron Smith, and we update the current node to be the next of the current node, which means that current node will now be pointing at Bobby Bear. At this point, our while loop ends. Our current node is not equal to none. Just like we did in our diagram example, we take the pointer of the previous node and point it to where the current node is pointing in its next pointer. This has the effect of deleting the node from the linked lists. We finally add a line of code that assigns current to null. This is a way of telling the operating system that we no longer need this value. Okay, so thank you for doing this video on linked lists. What are we supposed to take away from this? Well, what you're really supposed to understand is how linked lists work, that they are a dynamic data structure that distributes data throughout memory, but because of the links between that data allows you to insert and delete elements from that collection. Hey folks, it's Bobby Bear here, happy in my new job. This week I had to make a decision of what data container to use, and I had data that I knew wasn't going to change with insertions and deletions, so I decided not to use a linked list, but I used an array instead.